Let's review some of those class notes from this past week. This is the combined gas law, and what it allows you to do is calculate a change in pressure, volume, or temperature if you have the other values. So P is pressure, T stands for temperature, and V stands for volume. And you need to get used to looking for terms such as atmospheres in the word problem, or degrees Celsius, and if it is in degrees Celsius, don't forget to add 273 to convert it to Kelvin before you plug it back into the equation. Finally, volume is usually in milliliters or liters. All right. 1 means the conditions initially, and 2 stands for final conditions. Here's what a typical problem may look like. What I would do is start labeling things as I read it. So this is the initial volume, this is the initial temperature. You might just go ahead and add the, convert it to Kelvin right away. So 293 Kelvin, T1. Okay. And standard pressure, and you might say, what is standard pressure? Standard pressure is always 1 atmosphere. So that is P1. And what volume will it occupy as it rises? You already have an initial volume, so this must be final volume, or V2, that you're solving for. So that's a question mark. What will it occupy when this balloon rises to a new pressure, or P2, of 0.4 atmospheres and a new temperature of -20? Go ahead and add 273 to that temperature so that you can automatically have a Kelvin value to plug in later. Now it's just a matter of plugging into the equation. I always write the equation formula first and then substitute in. And so now we can actually go in, plug in all of our values. So you notice that if we look at the volumes, they're both in, we're solving for volume. So our V2 should be in liters. It'll be something liters. Our temperatures, now that they're both in Kelvin, you know that the units are going to cancel. And with the pressures, since we have both of them in atmospheres, those will cancel too. So there's no need for me right now to plug in the units into this equation. I would just go ahead and substitute in the numbers. And solve for V2. To solve for V2, you need to remove this value right here. So to get rid of this, what I would do is to multiply both sides by the reciprocal. So multiply both sides by 253 over 0.4. Make sure you do that to both sides. And by doing so, this will cancel, because any fraction multiplied by its inverse will cancel out, will equal to 1. So you, on the right hand side now, you have V2 equals this, which you need to simplify. So on your calculator, when you go to simplify that, you will end up with 3.10 liters. It's that easy. That's a little messy, but that's okay. Let me know if you have any more questions in class. Okay, the next law is called the ideal gas law, Piv-Nert. where the R is 0.0821 liter atmospheres per Kelvin mole. Or if you're dealing with kilopascals, it's liter times kilopascals per Kelvin mole. These are just units right here for that constant. N is moles, so we should make a note of that too. Here's a typical gas law problem. Now, here is STP. That represents T at 273 Kelvin, or the freezing point of water. And SP stands for standard pressure, or when pressure is 1 atmosphere at sea level. Now, volume, so there's our V. We have PVT, and with grams you can consider converting it to moles, so to N. So we have PV equals nRT. Solve for V, so to do that we divide both sides by P. So now V, so P cancels. Let's see here. P cancels. Okay. And so V equals nRT over P. And we can substitute in. Now for the to convert from grams to moles for carbon dioxide, that would be, we'll do that over here in the corner here. You would do 7.40 grams of CO2 times 1 mole over 44 grams. That's the molar mass of carbon dioxide. And you would end up with 0.168 moles of carbon dioxide. So that's N. This is N. And so I'm going to substitute it in right here. I'm going to use the R that allows me to cancel out the atmosphere unit. So that's going to be 0.0821 liter atmosphere per Kelvin mole. And T is 273 Kelvin. Now, make a big old division line there. See right there? Okay. Over P, and so P is 1 atmosphere pressure. And now you can just check the units, so that's super important. See what we have here for pens. So the atmosphere cancels, the moles cancel, the Kelvin unit cancels, and we're left with liters. And that's what we want because we're solving for volume. So this is going to be liters. It's really hard to write with this pen, so bear with me. And you should get 3.77 liters if you do this successfully, like so. Alright, so just make sure you check your units when you do this problem. Make sure they cancel where they're supposed to. And this is how you would show your work. Whoa, I'm not sure how that happened. Alright. The next problem, using PV equals nRT to find density. Well, this is a variation on the PV equals nRT formula. If you derive the formula for density, the AP test doesn't actually give you this formula, but if you do the actual derivation, what can happen is you can use what they give you as in the formula sheet. You will see that N can equal the mass divided by the molar mass, which is a large cursive M. And that makes sense because mass is measured in grams and molar mass is measured in grams per mole. So if you look at the algebra there, it does simplify out to a mole. So this is a new formula for you to consider. Well, if you consider Pivnert and you consider substituting this n, this m, little m over big M in for n, then you end up with this. And then if you really want density, density for gases is in grams per liter. So what they're really asking you to do is rearrange this equation so you have m over v. Well, to get m over v, you need to move v to the other side. So in other words, if you divide both sides by v, you're going to end up with mv, m over v. And so basically I can just divide both sides by v. The v will cancel out here and you'll have p on the one side. However, I just want m and v in this problem, so I'm going to get rid of m by multiplying by m. This is the molar mass. I'm going to get rid of RT by dividing by RT, and remember, what you do to one side you have to do to the other, so I'm going to put m over RT on the left as well. So now this drops out, this cancels to 1, and you have m over v, which is density. So writing that neatly now, density which happens to be m over v, is equal to m, and that's the sort of molar mass cursive-y looking one, p over RT. And then you can go about your merry way and solve for what they give you. So you take the molar mass of ammonia. So now I'm just substituting into these 4 variables. Capital M here is 17 grams per mole. That is the molar mass of ammonia. 14 for nitrogen, and 1 gram for each of the 3 hydrogens, times 752 millimeters of mercury. You're going to want to convert that to atmospheres. So it's 1 atmosphere, what you want over what you want to cancel. The unit you want to cancel is millimeters. Over, and again, since you see the atmospheres here, you're going to want 0.0821 liter atmospheres per Kelvin mole multiplied by T, which we need to convert to Kelvin, 328, okay. And when you solve that problem, you get 0.625 grams per liter. Okay? Alright, last problem here for the evening. So with this problem, they want you to calculate molar mass. And what you have to do there is consider that you're using PV equals nRT, and you're going to have to rearrange it. So what you would do is take the previous problem, so you now know that PV, oops, hold on, let's see if I can get around this, okay, PV, do you remember how N is equal to the molar mass, oops, let me fix that, little m, that is mass given over, of a sample, over its molar mass. So remember, this is a formula on the AP formula sheet. So again, instead of writing PV equals nRT, we can substitute that with PV equals little m over molar mass times RT. And then now we can rearrange that equation to solve for M, molar mass. So if we rearrange it to solve for molar mass, and I encourage you to do that on your own, you will discover that it ends up being density times RT over P. And substitute into that, so you have 7.71 grams per liter. And we've been pretty much, okay, we see the atmospheres here. That instructs us to use this particular R. And then the T is 36. So that would be 309 degrees. 309 degrees. And the denominator is 2.88 atmospheres pressure. And if you go about canceling all the units, you will see that you'll end up with grams per mole. That is not canceled. It ends up being 67.9 grams per mole. And you still need to determine the molecular formula using our method that we've done previously, where we need to find the whole number mole ratio of X. Doesn't look like it, but that's chlorine. So it's a whole number mole ratio of chlorine to oxygen. So you need to find these two values, X and Y. And that's just a matter of doing some more calculations. So starting with the molar mass, go back to chapter 3, I believe it is, 2 or 3, and see if you can go back and figure out how you calculate the molar mass based on the information we now know. It's more of a check and guess. Just as a hint, you might have to go back and look at the atomic mass of chlorine and oxygen. Okay, so that's all the formula, or all the review for tonight, and we'll see you later on as we do more, hopefully, review problems online for your review. See you later.